Hi guys, in this video we are going to derive the distance formula for calculating the distance between 2 points in the Cartesian plane, and also we are going to solve an example using the formula. We are going to calculate the distance between 2 points in a Cartesian plane using the formula. So let's go ahead and derive the formula for calculating the distance between 2 points. Assuming we have 2 points, let's say P1 is our first point and we have another point P2 here, and the coordinates of P1 is x1, y1, while the coordinate of P2 is x2, y2. Okay, in some cases we want to find the distance between these 2 points. So here we are going to derive the formula for calculating their distance, assuming the points are x1, y1 and x2, y2. So if you draw a line from P1 to P2, a straight line from P1 to P2, if you draw a line from P1 to P2, you can see that the length of this line is the distance between points P1 and P2. So let's call the length of this line D. So D is the distance between these 2 points. So here we are going to find the formula for calculating D, which is the distance between the 2 points x1, y1 and x2, y2. We'll project this point P1 horizontally to the right. Project it to the right. Then this point P2, we are going to project it downwards, vertically downwards. Then we have a point here. So let's call this point where they intersect P3. This point is x1, y1. That means this point will be x1. Here will be y1. This point here will be x2. And this point here will be y2. So this point is x2 and this point is y1. Therefore, the coordinate of P3, point 3, is x2, y1. So we have the coordinate of coordinate of P3 to be x2, y1. Now we can see that we have a right angle triangle here. And with the Pythagorean theorem, if you have a right angle triangle with sides A, B and C, then A squared is equal to B squared plus C squared with the Pythagorean theorem. So if you apply this here, this means that the distance from P1 to P2 all squared is equal to the distance from P1 to P3 all squared plus the distance from P2 to P3 all squared. So we can write that the distance from P1 to P2 all squared is equal to the distance from P1 to P3, distance from P1 to P3 all squared plus the distance from P3 to P2 all squared. All squared. We say that the distance from P1 to P2 is D. So D squared here. So we can write that D squared is equal to the distance from P1 to P3 all squared plus the distance from P3 to P2 all squared. The distance from P1 to P3 is the same as the distance from x1 to x2. If you see here, from P1 to P3 is the same as moving from x1 to x2. You know, if you have 2 points in an axis, to calculate the distance between the 2 points, we take the absolute value of the first point, x1, minus the other point, x2. So you can see that the distance from x1 to x2, to get the distance from x1 to x2, we take the absolute value of x1 minus x2, or we might take the absolute value of x2 minus x1 anyway, but here we'll just choose to take the absolute value of x1 minus x2. Since the distance from P1 to P3 is equal to the distance from x1 to x2, that means the distance from P1 to P3 is the absolute value of x1 minus x2. What of from P3 to P2? We can see that the distance from P3 to P2 is the same as the distance from y1 to y2. And to calculate the distance from y1 to y2, we take the absolute value of y1 minus y2. If you want to find the distance from y1 to y2, and since the distance from P3 to P2 is the same as y1 to y2, so we can substitute this for this and this for this. So here we now have that d squared is equal to the absolute value of x1 minus x2 squared plus the absolute value of y1 minus y2 all squared. We replace P1, P3 with x1 minus x2 and distance from P3 to P2 with the absolute value of y1 minus y2. In the formula for absolute value function, if you have the absolute value of a all squared, if you have the absolute value of a all squared, in the property of the absolute value function, the absolute value of a all squared is also equal to a squared. So if we apply this here, if you apply this property here, we now have that d squared is equal to x1 minus x2 all squared, because the absolute value of a all squared is equal to a squared. So we got this, and here we get that y1 minus y2 all squared. So d squared is equal to x1 minus x2 all squared plus y1 minus y2 all squared. So here now we can take the square root of both sides, and if we take the square root of both sides, we have that d is equal to the square root of x1 minus x2 all squared plus y1 minus y2 all squared. So you can see here now we found the formula for calculating d. So if you have 2 points here, x1 comma y1 and x2 comma y2, if you want to find the formula for calculating d, we have to take the square root of x1 minus x2 all squared plus y1 minus y2 all squared, and this is what we call the distance formula. Okay guys, now we have derived the distance formula here, so we are going to use this formula we derived for calculating the distance between 2 points. We are going to use it to calculate the distance between points -1, 2 and 2, 6. So here we have to find the distance between points -1, 2 and 2, 6. So if you call here our point 1 and call here point 2, so since here is point 1, here is x1, y1, while this is x2, y2. We can call here x1, y1 and here x2, y2. The order does not matter. We should just choose a point as our point 1 and point 2. The coordinates of our point 1 will take it to be x1, y1, and the coordinate of our point 2 to be x2, y2. So here now we want to find the distance between -1, 2 and 2, 6. We are going to plot this point in a plane so that you can see how they will look in the Cartesian coordinate plane. We have this point to be -1, 2 and this other point to be 2, 6. So if we draw a line here, me draw this line. This line here is the distance between these 2 points. I know to calculate it from the formula we got there. From the formula we got here, we have that d is equal to the square root of x1 minus x2 all squared plus y1 minus y2 all squared. So now to calculate their distance here, d will be equal to the square root of our x1 is minus 1, root of minus 1 minus x2, which is 2, all squared plus y1 2 minus y2, which is 6. So here we now have that, if we simplify this, we have that d is equal to the square root, d is equal to the square root of minus 3 all squared plus minus 4 all squared. So we have that d is equal to the square root of 9 plus 16. So d is equal to the square root of 25. The square root of 25 is plus or minus 5, but since we are dealing with distance, distance is always positive, so we have that the distance d is equal to 5, positive 5. So here we got that the distance from minus 1,2 to 2,6 is 5 units using the distance formula. So guys, this is all we have for today. Thank you for joining me to the end, and if you learned something from this video, please give me a like. But if you have any problem, you can reach me in the comment section and I'll get back to you as soon as possible. And also subscribe if you want more math videos like this. Thank you all. Have a nice day.